Hi, my name is Chris Berg. I'm CEO and head chef of Data Kitchen. I'd like to talk about the best practices in data ops or the data ops transformation. So in this discussion, we've got three basic sections. What, why data ops, or why does data ops exist and why it's essential? The next section is really the 7 steps of data ops, where we break apart the technical sort of background on how to achieve data ops from a principle standpoint. And then third part is where you can find and learn more about data ops itself. So while our company Data Kitchen's been around 5 years and talking about data ops, we used to call it agile analytic operations. The actual terms have gotten much more popular in the last year, and in fact the last 6 months since Gartner put it on its hype cycle. And I think that the reason for that is that Gartner put it on a hype cycle, that other analysts have started covering it, that people have become interested in it, is that as people do data and analytics, whether they do data engineering or they do data science or visualization or governance, they realize same things that my founders and I realized when we managed teams of data engineers and data scientists and people who do data viz, that the customers are always demanding. They always want something new. They always want new insight. And it's really actually hard to get requirements out of them ahead of time without putting something on their fingertips. And then the second is that your customers also have pretty low tolerance for errors. They don't like wrong data. They don't like late data. And then there's the third part is there's just this bloom of innovation in analytics, lots of new tools, lots of new techniques. And so how do you deliver data in analytics in any form, data visualizations, models, fast with high quality using the tools really, and to do that for the purpose of innovating. And I think that is really why the trend of data ops has taken off, because as data and analytics matured and people do it more, they realize that there's a big people and process problem. And so similarly, that happened in software development. I used to manage software teams in the 90s and 2000s. And, it was pretty good if you could ship software every 3 months. Sometimes it was longer, sometimes it was less, but shipping software every 3 months was pretty good. Now I couldn't get a job as a development manager shipping software. It'd have to be 3 seconds or 3 minutes. And why is that speed and delivery really matter? Well, it's because it allows you to fix things that are broke faster, get more feedback, and the automation to make that deployment happen has just become a lot easier. And similarly, in building cars and manufacturing, over this past maybe 50 years, 80 years, there's been a big change in how people think about um, managing a technically complex environment of a manufacturing line. An idea of lean manufacturing has really helped reduce waste, increase efficiency, reduces employee workload, satisfaction. And in fact, when I was a young boy and growing up in Wisconsin in the Midwest part of the US, the Japanese auto manufacturers actually started beating a bunch of American manufacturers. And the town I was in, Milwaukee, lost 50,000 jobs during that time, which was significant given the size of the town. And that was really, in a lot of ways, because of these ideas of lean manufacturing, because the Japanese cars and small engines were, in fact, better and cheaper than the American counterpart. And so, if we look at these ideas, sort of agile and lean and DevOps, well, why have they not been applied to data and analytics? And so, uh, I think that the reasons of in a couple of ways. The first is because is that innovative insights, you know, they're just the speed, the expectation of your customers is sort of an Amazon level expectation. Um, and they want things quickly delivered overnight. And they have very low tolerance for errors. Data quality is hard given the challenge of data suppliers and erroneous data, et cetera. And then it's just, since there's a lot of new technologies, how do you actually make changes? And so also there's these sort of longstanding dichotomies in the data and analytics world. One is can you develop new things and still protect what you have in production? The second is, can I do experiments and then sort of make those experiments reproducible so someone else can do them, or I could just do them again, 3 months later. The third part is there's a sort of a Hatfields and McCoy difference in data and analytics. There's a lot of what are called self-service tools like Paxata and Trifecta and Alteryx and Tableau, and tools that people could do a lot of work on their desktop and deliver a lot of value for their customers. And there are some people in organizations who are centralized, thinking that those tools give people too much freedom and have problems with data governance or desktop data marts, et cetera. And this centralization of control of who creates the data, who does the work on the data, versus distributing the control to individuals in the line of business is a long-standing challenge in analytics. And likewise, the differences between sharing something to a group and having individual control, or how do I take something that someone has done and reuse it. And so these, in our observation, these things are sort of long-standing challenges in analytics that help make it difficult to do data ops. And so I think the idea of data ops is fundamentally about a mindset change and how you think about doing your work. And so the first comes from an emotion, which is fear of change. And so I think all of us have delivered data to a customer and it's been wrong or it's been late, and we get sort of yelled at, or the customer's dissatisfied. And how do we stop that? Well, one way is to just slow things down and to slow down the pace of change, put in processes and documents, and put in change review boards. And that fear of change is a normal response, but it's difficult because in a very rapidly changing world, then you slow things down and your customers are happy in another way. So can you go from change fear to focusing on how fast can I make a change? What's the velocity of my change, and trying to optimize that? And then the second is the operational side of analytics hasn't gotten a lot of attention. And how do I deploy things? How do I test things? Where do I keep my work? Is that stuff done manually, or is it done with a Word document instead of a script? And so can you go from manual operations to doing automated operations and giving them the sort of respect and time it deserves? The third part is really, can you, instead of having hope, which is a great emotion, hope that something works, hope that your data is right, can you actually prove it? And instead of hoping for quality, can you integrate quality automatically in the work that you do? And then the fourth one is a tough one. There's a lot of cases where people like to be the hero. They like to do things at the last minute, or they've got do all the technical work themselves and sort of give it to the customer. The problem with being a hero is, I don't know if you've ever read the book The Phoenix Project, is that heroes end up being bottlenecks. And bottlenecks are one of the things that hurt the overall throughput of the organization and make it stop from being repeatable. So, having fear, there's nothing wrong with having fear a little bit of the time, and there's nothing wrong with being a hero a little bit of the time, and there's nothing wrong with having hope a little bit of the time. But those challenges slow down the ability slow down the ability of people to deliver high quality analytics repeatedly. And one of the other mindset changes in data ops is moving from a tool-centric way to a code-centric. And what do I mean by that? It's tools are, a lot of vendors, there's a $100 billion market in analytic tools. It's BI tools, data science tools, there's self-service tools, there's centralized tools, there's tools that you code, there's open source. And a lot of the tools are trying to say that they can do a lot of different things. And so I think the vendors are involved in kind of selling magic beans, that if you just do it in my tool, everything will be great. And the reality, it's there's different roles, different data, different tools. And so it's not about the tool, it's about the code that the tool creates and thinking about that code and the process that it works in. And so the diversity of tools, avoiding vendor lock-in, thinking about your tools, whether they're Tableau or Alteryx or a Python IDE or an ETL tool, as something that creates code in the software sense, is an important part of thinking on how to succeed in data ops. And so again, what is DataOps? Well, the goal really is continuous delivery of analytics of any form, data, models, etc. And so the benefits are that if you do follow DataOps principles, your insights come to your customer faster. So it's the actual uh, quality of those insights is higher, and you can then add more features, add more changes at the speed of business. And at the end, you've got a bunch of people who end up working better and are happier. And so we think about the intellectual heritage of DataOps coming from three buckets. One is Agile, which is sort of Agile software development, which is kind of the people process, Scrum, Kanban, stories, and then the technical environment, which is a little bit more from DevOps and lean manufacturing. Now, in the rest of this deck, we're not going to talk too much about Agile. There's a lot of books, videos, experts. So how you manage a team to be agile, whether you do Scrum or Kanban, whether you use Jira or a ticketing system, how you write your user stories. There's just a lot of expertise out there. We think that that's an unnecessary part of achieving DataOps, that agile attitude, focus on fast feedback, improving how you work with your team members. But in the rest, we're going to actually think that that's necessary but insufficient. The sufficiency comes from having a technical environment that supports DataOps. So what is that technical environment? What kind of sort of architecture that you should think about? And so that's what the next steps are, is what are the 7 steps of DataOps? And really they're the 7 steps of the technical environment that support Agile in a DataOps way. So those 7 steps, the first one is orchestrate 2 journeys. The second one is is adding tests and monitoring, and we're going to spend quite a bit of time on that. 3, use a version control system. 4, branch and merge. 5, use multiple environments. 6, reuse and containerize. And 7, parameterize your processing. And so these things have nothing to do with they're sort of best practices or principles that you should do in order to build the technical environment for DataOps. So the perspective, one of that perspectives on DataOps is that its heritage is manufacturing. That same idea actually plays out in a production system. And if you look at what we call the value pipeline and think of your production analytics, data comes in on one side from a variety of sources, and tools act on that data. Maybe it's some code to access the data in a script. Maybe there's a ETL or a data pipelining tool like Airflow. Maybe there's some predictive model that runs in R or Python. Maybe there's a visualization tool. Maybe there's some reports. All those things, think of them as stations on a manufacturing line. And data's passing beneath those, being added to, changed, artifacts are being added. And and at the very end of the assembly line is your final product, which your customer sees. And so that perspective of, in that manufacturing line, how do you make sure you have a quality product? There's ideas of just in time. There's ideas of how you would measure and monitor your production line to make sure it's working, and give your ability of your workers to stop the line. And also the assignment of blame is a key idea in Deming and production manufacturing and lean, and that usually problems in the production line are management problems. They're the overall design and process of manufacturing rather than a specific worker on the assembly line breaking something. And so the DataOps has a perspective that your production analytics are a manufacturing line, and that manufacturing line has workstations that data is passing through and artifacts. And each one of those workstations are really the tools that you use, and what programs those workstations are the code or configuration that are created by those tools. And so whether it's Python code or SQL code or R code, it's a software-driven production line. And that sort of leads to our next thought, is that in a lot of ways, once you have your production line running, your customers are going to immediately say, hey, what about this? And going to want to change it. And since you've got diverse customers and you've got a diverse team of people who are creating things to go on that time and diverse tools, you need another kind of pipeline, an innovation pipeline that takes the ideas that are created by those people on your team, data engineers and data scientists, built in the tools that they use, and take it and create a place for them to work, a development environment, and then help deploy those ideas from that development and idea into production. So the deliverables, the ideas, the code that your team creates moves from the idea in their head through their fingers to a keyboard to a tool, creates some code, and then moves from that into production. And so also think of your analytics as an assembly line. The challenge here is you got to do both at the same time, right? You've got your factory that's producing analytics running all the time, or running in batch, whatever your frequency is, and you just don't want to learn about data quality issues from your customer. You don't want to be late, and then likewise, you want to be able to pick that assembly line up and change it at any time, and you don't want to break it when you change it. And so that's a very hard thing to do, right? You've got a factory that you're constantly changing, but that's the expectation I think that our customers are asking us. How do you orchestrate all these tools, create a good pipeline of value that's going out, and then innovate on top of that? And so that's the first real perspective on DataOps. So the second part of DataOps is really adding automated monitoring and tests. And so the first part, that value pipeline where data is coming in and tools are acting upon it, et cetera. Think of that as monitoring. How do you monitor that that the data is correct when it comes in? That your code and tools are still working on it. And then the second perspective that we'll talk about is think of it as tests. How do you actually take, if you're in the idea business, those ideas are expressed in code and the configuration that drives your tools. If I change one part, how do I not break all the other parts that it works? And that's, think of that as testing. And similarly, the way software engineers test. And so we're going to talk through that and talk about what that means here, first monitoring and tests, and talk about how those are actually linked in a lot of ways. So first, how do you monitor production? And so, well, data's coming in, right? Has your data supplier given you bad data? That's a huge. Some companies have it easy. Some companies have it very hard. But is it shaped? Is it right? Is it sized? And when I mean monitoring here, I mean automated monitoring that runs at the same time that these systems are running. So as I get some data in, I put it in a lake, I form it, create some schemas, create some marts from it with my ETL tool, or whatever pipeline tool I have. I apply a predictive model, and as the data goes and artifacts are created, segments are added to it, more schemas added to it, you want to make sure that you're monitoring that those things are actually working. Why? Because sometimes you may not catch things in development, and you may want to find out that if it's broken. And then at the very end, you want to make sure that it looks good to your customer, that the outputs are consistent, and that actually running all those tests and monitors are actually a really important way to get a data set that you can use to analyze your activity. So saving those test and monitor results is actually good. But the main idea is automated, constant monitoring that's at every part of the process. And so if we think about what do those monitors and tests mean, well, different types. Some should be error out. The system shouldn't proceed. If you have an important data file, if a important system went down, well, just stop. Don't keep going. Something's wrong, and notify someone. And the other cases is more of a warning. Something looks weird. Maybe you should investigate. Data is not always black and white. And then that data set of all those tests actually allow you to kind of keep a history, and then allow you to do what's called statistical process control. If you've got a million rows, and suddenly you have 10 rows, that's out of bounds of what you've normally gotten. And perhaps that's wrong, perhaps that's weird. You should check it out, but you should know that before your customer sees it. And there's a lot of automated tests that you can make. Some are counts. Is the row count over 100? Does this table have this many columns in, or does it are the format of a certain column right? The field validation, is it in range? Does this field, is it 0 to 100? If you're going to get a list of physicians in the U.S. and the number is 10 million, that's probably wrong because there's only a million physicians in the U.S. And so those are basic tests to make sure that your data is actually right, or that it's working, that your transformations are working correctly. And those could be written in a lot of ways. Like you could just, every time the data is processing, do a select count from customers where it's above a threshold, or select count of customers where it's sort of larger or equal to the number than last time. So suddenly if your customers drop, that's something you should probably know about, and you should know about before your customers. So some of these are ways that you can just test as the data is processing to make sure things are running correctly. And you can write these in a lot of different languages. You can write them as big, complex SQL statements that you do, big except statements that either work or don't work. You can write them in Python, you can write them in R, you can write them in scripts. It's really these automated tests. It doesn't matter the language, it's just that they run every time that you're running. And so another type of automated test or production test is, instead of looking at a data set or a table in and of itself, you look at a group of data as it moves across your system. And a lot of analytics has sort of data hopping. It ends up in an FTP site, it ends up in a data lake, then ends up in a MART or some kind of schema, then it ends up in a set of rows and features in a predictive model, then ends up in a report. And so, if you get a source data of 1 million rows, which breaks up into, in this case, 300K facts and 700K dimensions, is that the same amount in the report? And you've got the same data in 3 different locations. And so how do you location balance across those to make sure you didn't have any lossy transformations or something didn't work? And, that's just an artifact of the chain of tools that we have in analytics. And sometimes there's caching that's done for performance. Sometimes in Tableau, online, you can do a cache, or your reporting system can have a cache. Sometimes you're building marts off of a lake, etc. But balancing the data amounts on a location are important. Another example test is, I think one of the idea of it is, in my experience, we've given analytics to business people, Excel spreadsheets, data files, nice reports, and within 2 seconds they look at it and go, it's wrong. And so how do they know that? Like, how can they very quickly tell that the data is wrong? And so they have a model of their business in their head, and that's informed by the data that you give them. And so a lot of times that model involves the major entities that they're thinking about, their suppliers or their customers. And a lot of times they're looking at, as an example, their top 10, top 20. And so one way that we've done to help capture that sort of complex semantic model is to do what's called a historical balance test. And really has something significant change between now and last time the data was updated to them. And so here's an example of a customer one. So in these 2 tables, one on the left is production and one on the right is pre-production. There's a bunch of SKUs and products. And there's different groupings of those products. And you can see between production and pre-production, the groupings change. That product group 1 is expanded, and product group 2. And that may be fine. That may be the way the data's changed or the configuration's changed for this run, or it may not be. It may be an error. But the point is, if you sum up the volume across those 2 product groups and then diff them between group 1 and group 2, you can tell pretty quickly that something's wrong. And this is, you should notice this before it goes out to your customer. Maybe this is, in fact, the world's changed, and this product groupings has changed, and someone high up has said, or maybe it hasn't, but you should release note it, tell them, notify them. And this is also the way that they look at the world. If they're looking at their major product groups and suddenly the volume drops in one, they're going to go, what's wrong? My sales have suddenly dropped. And that's in that 2 seconds, they would tell you that something's wrong. So these kind of historical balance tests on the major entities that you do, looking between current and previous versions, are a way to help you capture this. And like with any test, you don't have to check everything. There's sort of your top 10, top 20, 80, 10, 80-20 rules that apply here. But we're trying to capture this before your customer sees it. So that's an example of like production runs. And so one of the other key is like, how do you test what you're doing in development? And so a key idea here is that those tests that you've created in, or monitors that you've created in production that run, they should also be run during development. So let's say I've got 100 tests that run every time my production build runs. I should run 90 of those, maybe 100 of those, maybe even more, against a test data set in development. And I should do that before I actually merge in production. And the purpose of that is those tests actually become more regression tests, functional tests. They actually become more like software engineer tests, because it's proving that my system works, and it's handling instead of having to go to that person who's got the hero, who's got the whole system in their head, you can actually go in and see the test results, provide a way to actually prove that you haven't broken anything in this complex network of systems and tools and data. And so one way to think about this is that there's a duality of tests. So, the quality that your customer receives, think of it as a function of your data and your code. And it's probably your data and your code and your hardware, but like to simplify it to your data and your code. And so these automated tests or monitors kind of serve a dual purpose. In production, your code is fixed, it doesn't change, but your data is variable. So in that value pipeline in production. And so those tests or monitors are really, testing the variability of the data. And of course, the code that's acting upon it, but primarily is the data variability. And in a development environment, those same tests are working on a fixed data set. Maybe it's last week's copy of production data. Maybe it's a test data set that you have that's cleaned and smaller, but it's still it's a fixed data set. But what's changed is your code, because you've changed some code in development, and so you want to do more regression functional performance tests. But really the same set of tests, largely the same, the intersection of your monitors in production or your tests or development is quite large. It should, and that that duality of those tests, I think, is really, really important. And it allows you that leverage to be able to go fast, because actually the quality of your automated tests is, I think, one of the main determinants of how much you can trust your system to deploy quickly, and how much your business users will trust your results, because you stop having errors, and and your automated tests catch things before they go into it. And we guide people to think of 20% of their work should be some form of automated tests. And that may seem crazy to people, but I worked at Microsoft for a while. They had one automated test engineer for every software engineer. So if you think about it that way, that's a 1-to-1 ratio, not a 1-to-5 ratio. So what I'm asking, I don't think is huge, but it is actually really important part of doing DataOps, and it's being able to build an automated test suite and run that automated test suite in production, run it in development, is a linchpin of a success in DataOps. And so the third part of the 7 steps to DataOps is using a version control system. And we've been giving a version of this or a type of this presentation now for 4 years. And at a lot of conferences, we had to explain what a version control system is and what Git is, and saying that it's like sort of like Excel track changes, and that you put all your work in it. The Python code, the ETL code, the R code, the Tableau code, all your work should go into one place. Not on a file system, not on your disk drive, but in a version control system where you can know who changed it, know what version you have, etc. This is sort of table stakes in software development, but unfortunately not table stakes in data and analytics development. And its benefit is that it's if you've got a lot of stuff in different places, it's centralized. And really, if you at a high level, you think you're trying to help your company be a data-driven organization. And if you really believe that you should help your company be a data-driven organization, what drives that data is code. And that's actually the intellectual property of your data-driven organization. And that should be kept in one place and versioned, and secured and backed up. So keeping that in Git, we think, is an essential part of being a data-driven organization. And so one of the benefits of having version control is you can do something called branch and merge. And so if you ever go into a software engineering managers, you see this sort of strange diagram here, and where the middle bar goes across is kind of what's in production. But then people create branches from production. So they take a copy of the code from production, they make a change to it, and then they merge it back, and that's those arrows back into production. And so tools like Git or any source control tool help you make branches and merge those branches back. And sometimes in data and analytics, it can be hard because, the XML format of Tableau is difficult to merge, and sometimes you have to do more of a kill and fill than actually do individual sub-file source code merging. But that's getting better. And an example of branching and merging is you may have in agile processes, you may have a main or a master of a trunk, and then you create a sprint branch, and then people create feature branches off that sprint branch, and they get merged back in. And sometimes feature 1 gets merged back in feature 3. Here's feature 2. Sometimes it gets merged back into sprint 1. Sometimes it can go merge back into sprint 2. But the idea of a master, a sprint branch, and a feature branch is one example of how people work with version control systems. And so the fifth idea is around using multiple environments. And so in that case, we are trying to, since your data and your code run in an analytic environment, which is hardware, software, the versions of the software, you need to coordinate those things so you get the same results. You don't want to have a different version of the library with the same code. You may end up with really hairy problems. And so coordinating, thinking of your infrastructure as as pets, or as cattle, not pets, as something that you can kind of, there's another term, infrastructure as code, where you can script this creation of the infrastructure, is an important part. And a lot of that has come out of the DevOps work that's been done for software engineering. And there's a linkage between these multiple environments and branching and merging. So analysts or people in data and analytics need a place to do their work. That's controlled environment for their experiments. And the control comes from, I've got a version of my production system that's for my development environment. It's got the same type of hardware, the same software, the same version of libraries. It's got some test data that's reflective of production. And it's my code that's the same code as in production, but on a branch, a Git branch. And so you can do your work in that separate environment. And it's surprisingly hard to actually create a sandbox environment for people. Because what you want to do in that sandbox environment is make your change and then add a new test and then run your new test as well as all the previous tests to make sure you haven't merged anything, and do that in a technical environment that's reflective of production. And so these sandboxes are kind of complicated because you want to have people in them, you want to have the correct version of your team's analytic tools, you want to have that code branch you're on, you want to have the right hardware and software versions, the right network configuration, you want to have your right test data sets, and when you run, you want to be able to kind of scope it to that environment so you get a very tight, so develop a little, test a little, develop a little, test a little environment. So creating sandboxes is a little bit difficult, and in fact more difficult than I've seen in software environment, where you hire a software engineer and they spend the first two or three days getting their dev box working, and then by and large their dev box is the same for the rest of the time they work there. Because sandboxes, given the complexity and the amount of tools in the tool chain, and the idea of creating sort of a disposable sandbox that they can use, that the sandbox should represent production. The cloud offers you a lot of opportunities there. And then the sixth idea, and before we get to the sixth out of the seventh, is the idea of reusing or containerizing. And so if you think of analytics as a code business, code is complexity. And so there's sort of ideas in how you handle that complexity. One is don't create big monoliths of code. Make code in some ways is communication. And so you want to make sure that you don't have really complicated workbooks or predictive models that are impenetrably pages and pages of code that can be broken up into units so that different people can come in, and that you can hire someone to replace someone else, that people don't build their own sort of crystal castle edifice of complexity. And you should allow people to reuse bits of code and results and refactor those codes and improve it. Likewise, there's some technologies to virtualize or containerize environments like Docker or Amazon Machine that are important, because then you can take your software and sort of wrap it up in a container. And then that means you can really practice environment version control, scriptable environments. And that's another key idea and a key enabling technology. And the cloud has some of this, Docker, Kubernetes, they've all been, they're all great technologies to accomplish this goal. And then the last point is really parameterizing your processing. And so think of your pipelines that you're building that contain all those tools that have the code that you pour the data in. Think of them like big functions. And so you want parameters on that function. You don't want to run all of it. Maybe it takes 5 hours to run. You just want to run the first half or just run the middle, just the end. I just want to run part of it. I want to run it the same thing with test data. So I want to change my test thresholds across all these things to make sure it runs. And so with these parameters, you can vary the inputs, the outputs, the steps in the workflow. You can even make a time machine. So I want to be able to say, I want to run, given my raw data of 2 weeks ago, I want to run the same process. And so those parameters themselves are actually important, because a lot of those parameters are security tokens that you use to log into different machines. And so if I'm going to run on a different piece of hardware, well, I've got to have the authorization to run on that hardware. So you need secure storage for your credentials. And so if we look at this in action, what do all the 7 steps mean? And I'll run through a short example here. So in whatever agile process you're doing, let's say you're going to select a story or a requirement. From there, you're going to create a branch in Git. And from there, you're going to create the environment to work in. That's got your test data, it's got your hardware, your software. And then in that environment, you're going to implement the feature. And you're going to write new tests on that feature. Let's say you're going to add a segmentation model. Now you're going to run that new feature and all the existing tests, which help prove that your new feature works, but also prove they haven't broken anything else, either behind your new feature or in front of it. Then you're going to check that code into a branch, and that branch is going to be merged to the parent or branch, so it's ready to be deployed to production. And then you'll delete that development environment. And then it depends. There's techniques on how people take that new code and deploy it into production. Sometimes that feature branch gets merged up. Sometimes then it gets placed into production. Sometimes there's deployment patches. There's different steps that people have to go through. But that's the idea, is that there's a bound, known, scriptable way to make that code that you've developed and put it into production. And so just to finish up, what are the next steps that you can do with DataOps? Well, the first thing is that, Data Kitchen's a software company. We have a set of software that actually implements all these 7 steps, and we use a lot of food metaphors to do it. So we can. That's one thing that you could look at. The next is that we have something. This is 7 steps. If you like a number bigger than 7, we have something called the DataOps Manifesto, which lays out these ideas in a little bit more granular form. I think there's 13 or 18 of these steps. We've had 4,000 people sign it. It's another way to think about how you should do DataOps and what the principles are. Also, you could contact me. We wrote a book. We have a blog. We are on Twitter a lot, that you can learn more about DataOps. So that's it. I want to thank you for your time, and have a good day.